Yeah, I'd like to introduce Luisa Pagoro. Oh man, sorry. I'm just gonna go with Luisa. I was feeling confident about her last name, but so she's a self-taught software engineer and started as a front engineer in JavaScript and React, and now exploring backend while writing Python code at a fintech startup. I'm so excited she's been giving an intro talk about Pydantic. So take it away, Luisa.
Thanks, Dan. Okay, so hi everyone. My name is Luisa. Like Dan said, I'm a software engineer. I started a few years ago coding in JavaScript and React, but now I'm switching over to Python. And I currently work for a US-based startup in the fintech world. And tonight I wanted to introduce you to a parsing library, Python parsing library called Pydantic. I don't have any slides, but I wanted to jump right into the documentation for Pydantic. That's how I usually get started when I'm trying to learn a new library or framework. So I'm sharing my screen. I hope you can all see it. This is just the landing page for Pydantic documentation. As it says here, Pydantic reports type-ins at runtime and provides user-friendly errors when data is invalid. So I'll just give you an example of how I use it or how I've been using it with my team. I've been using it for about a couple of months now, and we have a few API endpoints. So we have a client that sends us information, and we want to make sure that the type of data that is sent from the client matches the type of the data in our data. Yeah. There's a bit of background noise. I'm not sure. Okay, thanks. So as I was saying, we want to make sure that the type of the data that is sent from the client matches the type of the data in our data model. And so we've been using Pydantic to just do this parsing and also validation. I wanted to point out really quickly at the bottom of this page, there's discussion of Pydantic. There are a few podcasts and video. I watched the first one, Talk Python to Me. Actually, Samuel Colvin, who's the creator of Pydantic, gives a bit of an overview of the library and how it was born and the reasoning behind it. And the last one also is pretty interesting, the 20-minute talk, so a pretty good introduction to Pydantic. I will not be going over install page. It's very straightforward, whether you use pip or conda. You can just do a very quick install Pydantic with whatever package manager, your preferred package manager. And in a few minutes or even less than that, it will add the library to your virtual environment. So let's just jump right into it. I'm going to start from the models page. So the base model is the object, it's the most important object in Pydantic. And it's basically the base feature of Pydantic, and it's the one that you will use to subclass all your custom classes. There is a note here. I'm going to read the first few lines because I think it's very important to make a distinction between parsing and validation. And this notion of Pydantic being a parsing library is sprinkled throughout the documentation. But let's see what they're trying to tell us. Okay, so Pydantic is primarily a parsing library, not a validation library. Validation is a means to an end, building a model which conforms to the types and constraints provided. In other words, Pydantic guarantees the types and constraints of the output model, not the input data. I don't know about you, but this sounds a little bit abstract to me. So I thought that we could go through a couple of examples, and maybe this distinction between parsing and validation would be a little bit more clear. So I'm actually going to use the same example that's used here in the documentation. This is as easy as it gets of how you can use Pydantic. So you can just import the base model from the library, and then here they have an example with where they define the user class. So again, it could be describing your API endpoint, right? And the subclass is the base model, and it's just saying, okay, we wanted to have two fields, an ID of type integer, and the name. Here they defaulted to Jane Doe, and basically the type was inferred to be a string. Okay, so now let's go through an example. I have the same example from the documentation to just keep it simple. Again, I import Pydantic. We have the user class. And we define name here. Instead of defaulting it, we define the type of it as to be string. And now we go and we try to apply and instantiate our user class. Okay, so we create the user one. We provide it with an ID. Oh, and important to remember that when you're instantiating your class, you need to provide key value pairs. So you have to tell it the name of the key and also provided the value. So we provided an ID of 1 and we give it a name, just random Maria, and it's a string, okay? And then we're trying to see, okay, how does Pydantic interpret this information, right? So we can just run this script. I have everything already set out. I imported the virtual environment already. So we're just gonna run it and see what happens. Cool, all right, so Pydantic gave us back a user ID that has an ID of 1, and it's of an integer as we expected. And same thing for the name. Its name is Maria, and it's of type string. Great, so this is what we were expecting. Nothing really surprising here. But let's go through another example. Let's say the user, let's say it's a form that the user trying to fill out and they make some mistakes, okay? And the next user is created by providing an ID that is not really an integer, it's a float. So here in our example, we have ID 3.14. And the name, again, that's another mistake. Our user is really tired, and instead of putting their actual name, they just put a number. I'm going to throw it back at the audience. What do you think is going to happen in this instance? Do you think Pydantic is going to scream at us and be like, hey, no, these are not the types that I was expecting? Or do you think it's going to do something else? Anyone, maybe in the chat, you can post.
I'm hoping it'll scream at us. I don't know.
Scream at us. Okay, so we have 1 vote for screaming at us. Anybody else? No?
Add another vote in chat for scream.
Another scream. Okay, let's try for screaming. Let's see. Let's give it a whirl. Well, no, it did not scream at us. That's a little bit surprising, isn't it? Why? Why is this happening? Well, this is it is going back to the definition and that distinction between parsing and validation. So here, Pydantic is basically saying, sure, you're giving me a float, but I can actually cast this to be an integer. And so I will just do that. And the same thing with the name. Yeah, sure. You gave me an integer, but I can actually convert it to a string. And so this might be the desired behavior, but let's imagine, for example, that this user ID is really the amount for a transaction, right? It goes from 3.14 to 3. So we've actually lost some information. I don't know about you, but I do care about my 0.14 cents. So this is just a note, on how to make sure that you understand how to use Pydantic and why they put so much emphasis on the fact that really it's a parsing library and not, it should be used mainly as a parsing library and not as a validation one. Having said that, in my team, we use it mostly as a validation tool, but you should definitely be aware of this behavior and make sure that it fits your business needs. I have a last example for you. So this time, instead of this time, we'll provide the date time for the name. And again, do we have any guesses on what Pydantic is going to do? Scream at us or try to cast it.
Maybe it'll cast it now.
Maybe we'll cast it. I don't know. Let's see, let's try it again. This time it's actually screaming back at us and it's saying, hey, no, there's a validation error for username. I was really expecting a string. So in this case, Pydantic is not able to translate the date time into a string. And what I really liked about Pydantic is that it gives you pretty clear error messages. It will tell you exactly which field is having an issue casting with, and it's very useful when you're debugging and when you're, you need to get things done very quick. So this is one of the features that I really, really like about Pydantic. So that was pretty much it. There's a lot of other features out there that Pydantic provides. There's more validation. It does provide support for the standard library types. It has its custom types. It builds on top of Python's data classes. I am myself learning a lot about it, but I hope I piqued your interest, and hopefully you will try it out. Maybe you will adopt it in your application. And I would love to hear from you, in the next Python meetup, and see if anybody has experienced it. Yes, we do use also my type. That's sorry, I'm looking at the question in the chat. Yes, we do also use my py for static type checking. Pydantic is more for runtime checking. So yeah, so that was it for me. I will pass it over to Eli, who is actually going to be talking about Fast API, which coincidentally also leverages Pydantic. So thanks again for having me.
Is there any other questions for Luisa? I'll ask one, Luisa, what do you use Pydantic for?
We use it mostly for API validation endpoints. So I really like it because it will tell you right away what is wrong with any input that the user might provide. And so it's easier than catching it downstream. It's much faster.
Great, thanks.
Thank you.
Any other questions, anyone? Great, thanks so much, Luisa, for giving the opening talk. That was a lot of fun learning more about Pydantic. So thanks so much.